So the topic of discussion now is constraint motion of pulley block system. The first question comes in your mind is that what is constraint motion? Now if you recall a previous lecture, we have talked about the motion of a sledge dog system. Let's recall that figure very quickly and briefly. This is a sledge, say, and this is the dog ahead of the sledge, and there is a belt that is fastened around the dog's neck collar, and that way the dog and the sledge are connected. So if this belt remains taut and it does not stretch at the same time, then you can say that if suppose at an instant acceleration of the dog is a1 and the acceleration of the sledge is a2. So we can argue that if the belt remains taut and they just very firmly fasten these two items together, in that case at any given instant a1 must be equal to a2. Now this is called the condition of constrained motion between the sledge and the dog. First of all, the dog and the sledge are in constrained motion because they are fastened together by a belt and their motion are interdependent. They depend on each other. As a result, we found of an additional condition that we needed to apply in addition to Newton's laws, and that equation was their accelerations must be equal. Now this is the additional condition that we shall call constraint. Just look at this physical jargon. This is constraint. That is the additional condition which is coming because of the interdependence of the motion of the sledge and the dog. And the motion is called a constrained motion. So you see, this is a simple example where you found accelerations happen to be equal. But there are more complicated cases of, say, in a pulley block system, in a wedge block system, we will find out that two or more bodies that remain interconnected by a belt, by a string, and so on, their velocities or accelerations at an instant, they may depend on each other by a more complicated equation than this. And they are all examples of constrained motion. We shall see them with some examples. And remember, in each of them we require to apply Newton's laws of motion along with the additional constraint that again depends on the time of dependence between the motions of the connected objects. We shall mainly study about two types of system. One is called a pulley block system, as we shall see shortly. Pulley block system. And the other type of system whose constrained motion will be discussed in my classes will be the case of wedge block system. Wedge block. So let us first start with the case of pulley block system. We shall know what is the meaning of a pulley and how the pulley and blocks are connected and how the accelerations or velocities of those blocks may be dependent on each other depending on the type of connection between them. So let's begin with a pulley. As you can see on the screen, the pulley is a wheel that can rotate freely about an axle that passes through its center. And is usually connected to, with the help of a framework, to a fixed point so that pulleys can be either fixed or movable. So in this case, I'm just attaching it to the ceiling. As you can see, the framework attached to the center of the pulley through which the axle passes, of course. This is the ceiling from where the pulley is suspended. And in the simplest example, you will find a rope that does not stretch, an inextensible string that passes over the pulley like this. As you can see, that look at the figure, this is the same string, only one single string, continuous string, that is not stretchable, and it hangs on both sides of the pulley, and a portion of the string, it just wraps around the upper portion of the pulley. As you can see, it's leaving the surface of the pulley from diametrically opposite points. That is the same plane at the center. That's the usual case, and this is one single string. And we can attach two blocks like this at the two ends of these hanging ends of the string that passes over the pulley. So this was the simplest picture of a pulley block system, and I think I have mentioned this figure earlier in a previous lecture on free body diagrams. So that simple instrument or the pulley block assembly is known as Atwood's machine, named after the person who first invented it, Atwood's machine. And this was the easiest and the simplest picture of a pulley block system. Once again, that's the rotating wheel that can rotate freely about an axle through its center being attached with the help of a framework to a fixed point on the ceiling. One single string wraps around this pulley, and so that you can see these are the straight vertical portions, and here is a portion that is in contact with the pulley, leaving the pulley surface at diametrically opposite points. Two blocks of different masses usually are hanging at the two ends of the pulley, so that one block goes down and the other block goes up under the force of gravity. So we can just remember a few things. If the masses of these blocks was, say this was block number 1 and this is block number 2, and if M1 and M2 are their masses, and if M1 is more than M2, it is obvious that the block 1 will go down with an acceleration a, and the block 2 will go up with an acceleration, I can call it minus using vector symbol. This was a case of constrained motion, because since they are connected by a string that does not stretch under the weights, we can assume that both the blocks should move with the same acceleration. While one goes downward, two goes upward, but the magnitude of the acceleration remains the same in both cases. So recalling a few more things from the discussion of free body diagrams I have done before, I leave this job to you to show that, well, I'll come back to the figure, the tension in the string, if T is called the tension in the string, we had derived in that lecture that acceleration of either block is given a magnitude by m1 minus m2 into g, where g of course is the free fall acceleration, divided by the sum of the masses of the block. That was the result number 1. And the tension in the string was found to be 2m1 m2g divided by m1 plus m2. These two results obtained earlier in a previous lecture, so I give you this small work to prove without consulting any source. Of course, the acceleration is given by this and tension in the string is given by this expression. These are two results obtained earlier by us. Now, if you recall correctly, then in doing this problem, we had made certain assumptions to make pulley block problems easier for us. Those 4 assumptions now are introduced on the screen. Let us see what assumptions we need to make in pulley block problems to make calculations easier. First of all, the length of the string does not change under the weight carried by it. This is the string that is here, and you can assume it's inextensible. There are different words used to explain that behavior. The string is called inextensible or inelastic or flexible. All these 3 terms are used alternately to mean that the string length does not change under the weights of the blocks carried by it. First assumption. Second assumption, the string is taken to be massless. It's of negligible mass taken. The pulley is frictionless. There is no friction in between the pulley surface and the string passing over it. And the pulley is massless. So you see, these 4 assumptions make the calculations of pulley block problems much easier for us. The first assumption regarding the length of the string is required because we can construct a simple constraint equation involving the accelerations or velocities of these masses being connected only if the length of the string is assumed to be constant. While conditions 2, 3 and 4 help us to assume that the tension over the length of the string on either side of the pulley must remain constant throughout. So once again, condition number 1, the constancy of length of the string ensures that we can create a simple constraint equation, like in this case A1 and A2 are equal in magnitude. Some more difficult or complex equations might also evolve, but you must consider in that case string's length is constant and the conditions 2 to 4 ensure that tension of the string remains the same everywhere along its length. With these assumptions and the first example, we shall go to consider a couple of more difficult situations involving Pulley block system.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.